Hi friends. So in this video, we will discuss about active and inactive relationships in Power BI. In Power BI, relationships between tables can be either active or inactive. That means active relationships can be enabled by default. So that means when you create a relationship between two tables, it's active by default. Then used in calculations. Active relationships are used to calculate measures such as sums, averages and counts. So this can affect data filtering. So active relationships can filter data in related tables. Then can impact performance. Active relationships can impact report performance, especially if the related tables are large. Then inactive relationships. Inactive relationship means it can be disabled by default. That means inactive relationships are not used by default. They're not used in calculations. That is, inactive relationships are not used to calculate measures. Then no impact on data filtering. Inactive relationships do not filter data in related tables. And no performance impact. Inactive relationships do not impact report performance. So mainly we are using inactive relationships in data validation, data exploration, complex data models. Okay. So now we'll discuss active and inactive relationships with an example. So here uh, in this figure we can see that the sales data. So the sales data table contains two data fields, that is order data and stock data. But they can only be one active relationship to the date key in the calendar table. So you can set relationships to active or inactive from either the edit relationships dialog box or the properties. So you must deactivate one before activating the another. So in this figure, the sales data table contains two date fields, that is order data and stock date. If you look, you can see in that figure, there is the sales data table contains two date fields, that is order date and a stock date. Okay, but there can only be one active relationship to the date key in the calendar table. So you can set relationships to active or inactive from either the edit relationships dialog box or the properties. You can see their figure edit relationship. From there you can select the relationship to active or inactive or from the properties. Okay, so you must deactivate one before activating the another. Next one is relationship cardinality. Cardinality mainly refers to the uniqueness of values in a column. So ideally, all relationships in the data model should follow a one-to-many cardinality. One instance of each primary key and many instances of each foreign key. So in this example, there is only one instance of each product key in the product table. You can see here noted by A1. Since each row contains attributes of a single product like name, SKU, description, price, etc. So there are many instances of each product key in the sales table, noted by an here you can see that asterisk, since there are multiple sales for each product. So in this example, this is an example of one-to-one cardinality. Here you can see connecting the two tables above using the product ID will create a one-to-one relationship, since each product ID only appears once in each table. And this isn't necessarily a bad relationship, but you can simplify the model by merging the tables into a single valid dimension table. Then another thing you have to note here is this still respects the rules of normalization, since all rows are unique and capture product specific attributes. Next one is many-to-many cardinality. So you can see two figures here, product lookup and sales tables, and the relationship has cardinality many, and this should only be used if it is expected that neither column product ID and product ID contains unique values, and that the significantly different behavior of many relationship is understood. So if you try to connect the tables above using product ID, we will get many to many relationship. And warning, since there are multiple instances of product ID in both tables. So even if you force the relationship, how would we know which product was actually sold on each date, like cream soda or diet cream soda? Next one, connecting multiple fact tables. This model contains two fact tables, sales data and returns data. Since there is no primary or foreign key relationship, we can't connect them directly to each other. So, but we can connect each fact table to related lookups, which will allow us to filter both sales and returns data using fields from any shared lookup tables. So we can view orders and return by product since both tables relate to product lookup. But we can't view return by customer since no relationship exists. So very important point that you have to remember is, generally speaking, fact tables should connect through shared dimension tables and not directly to each other. Next one is filter context and flow. So here we have two data tables, sales data and returns data. Can be connected to territory lookup. So the arrow shows the filter direction and point from the one side of the relationship to the many side. That is, asterisk can be used to show that. So when you filter a table, that filter context is passed to any related downstream tables following the arrow's direction. So filtered context cannot flow upstream. So the point you have to remember is, arrange lookup tables above fact tables in your model as a visual reminder that filters always flow downstream. Okay, next one is bidirectional filters. Okay, so updating the cross filter direction from single to both will allows filters context to flow in either direction. So in this example, you can see filters applied to the sales table can pass up to the territory lookup table, then downs to returns. This is actually called bidirectional filters. Next one is ambiguity. So use two-way filters carefully and only when necessary. So using multiple two-way filters can cause ambiguity by introducing multiple filter paths between tables. So you can't create a direct active relationship between sales data and product lookup because that would introduce ambiguity. So between tables and product lookup and territory lookup. So to make this relationship active, deactive or delete one of the relationship between product lookup and territory lookup first. Okay. So in this example, if you look that, can see that filter context from the product table can pass down to returns and up to territory lookup, and that will be filtered based on the territory keys passed from the return table. So with an active relationship between product and sales as well, filter context could pass through either the sales or return tables to reach the territory lookup table, and which could yield conflict in the filter context. So the point you have to remember is that when you design your models with one-way filters and one-many cardinality, unless more complex relationships are absolutely necessary. Next one is hiding fields. So in this figure, if you look and see an option that hide in a report view. So hide in report view makes fields inaccessible from the report tab, but still available in data and model views. So this can be controlled by right-clicking a field in the data or model view, or by selecting is hidden in the properties pane. This is commonly used to prevent users from filtering using invalid fields, so that can reduce clutter or to hide irrelevant metrics from view. The important point that you have to remember is, hide the foreign keys in fact tables to force users to filter using primary keys in dimension tables. Next one is model layouts. So already we discussed about model layouts in previous video. So model layouts will allow us to create custom views to show specific portions of large complex models. So here we have created a sales view displaying only tables related to sales, and a return view displaying only tables related to returns. So note that this doesn't actually create a duplicate tables. Data formats and categories. So here you can see that format text. So this will customize data formats from the column tools menu in the data view or the properties pane in the model view. Then next you can see in category, data category, you can see country. This can assign data categories for geospatial fields, URLs or barcodes. And you can see a figure there that shows the map, and this is commonly used to help Power BI map location based fields like addresses, countries, cities, coordinates, zip codes, etc. So hierarchies. Hierarchies are actually a group of columns that reflect multiple levels of granularity. So for example, a geography hierarchy that might include country, state and city fields. So hierarchies are treated as a single item in tables and reports, and this will allow users to drill up and drill down through each level. So in the first figure you can see you have to select the create hierarchy option. That is, in the data pane, right click a field and select a create hierarchy. Then second figure you can see territory hierarchy. There you have continent. So this hierarchy contains continent and is named as territory hierarchy. Third figure, if you look, you can see territory. When you select territory hierarchy, right click another field like country and select add to hierarchy or drag it in. Okay. So this is all about this video. I hope this video will be very useful for all of you. And if you like the video, please subscribe, like, comment. Thank you.